Good morning, everyone. So welcome to this session on SQL Firewall, part of the Database Security Special Interest Group series. So today's session, we have the following agenda for the SQL Firewall. We take you through why we actually had this feature, why we thought there is a need for this feature. Then we introduce what is SQL Firewall, the use cases, how do you get started, and what are the common questions that you might probably get in like once you start implementing these features, right? And the next steps. Now, let me just give you a brief of what we are trying to solve with this feature. It's if you're in the industry of security, you wouldn't have it's very rare that you wouldn't have come across this SQL injection risk. It's one of the high on the OWASP top 10 of the application vulnerability. It's a dangerous attack pattern on the database where, the infiltrator can actually add some of the malicious input into the parameterized form or into any data-driven parameters which is exposed in the application, and the application thinks that it is one of the genuine requests, but if it's a malicious SQL string, it can retrieve potentially a lot of data which is not intended to be exposed, right? Beyond even exposing those data, the SQL injection has the flexibility to modify or do some changes in the database as such. So it is quite popular in terms of what the risk it carries. And it's quite easy because it's from the application, it's a prevalent one, like as you would have already heard about it. Now, just to give you a flavor of the risk factor that we are dealing with, like this risk has been the top 10 OWASP web application security risk, and it's not just it has been discovered a year or two back, right? It has been the top 3 most serious risks since 2017. And of course, you would have heard about this URL, the SQL Injection Hall of Shame, where there is a list of all the attacks that has stemmed out of SQL injection. The most popular is the move it file transfer, which was all in news since July 2023, and it's still in news. Now it's become so popular that some of the regulatory bodies, the top regulatory bodies like the CISA, the America Cyber Defense Agency, and the FBI, they have actually given the Secure by Design alert, eliminating SQL injection vulnerabilities. Talking about, if you look at this reference, it talks about the best practices of what the industry should do, what any company should do, apart from taking the responsibility and accountability. How do they manage these SQL injection, the prevention strategies within their organization? It's a quite good read to look at. But the most talking thing is it's on high alert. Like it's been trending since it on the upward curve since 2021, but we are in a decade where everyone notices that SQL injection is something that cannot be ignored. And this move it file transfer was quite simple. It's a managed file application, which is inadvertently it's quite it looks at the like the databases like MySQL, MS SQL, Azure SQL, and it does the file transfer. So the SQL injection vulnerabilities that was present at that point, it gave a handhold for the remote execution. So the infiltrator could actually do some command execution, which gave them the to install a web shell root, and that proved a way for people to start exfiltrating the data. And of course, there were downstream impact, like ransomware group was involved when the exfiltration started. And there were so many things, like a lot of organizations across the globe were impacted by this. And that's why, there is a high alert on the SQL injection. Now, let's take a high level look at the problem to appreciate why we have developed such a solution, right? So at high level, like a typical 3-tier application, you will have client, application, and the database. The client issues the queries to the application. Application typically has a service account which connects to the database. And this service account is usually privileged because it has to run any of the queries that is given from the client, right? So it has those access to the application schema. It has the access to run the procedures. It has access to all the underlying objects, metadata for any of the queries that is to be done. Now, what happens in a typical SQL injection case is like the user gives a malicious input into those fields, and the application doesn't realize what's going on because that's a parameter that is expected. And that's passed on to the database, and the database returns those results which are never intended to be returned by the application. Now, the question is like, where should we fix this problem? Now, traditionally, like there were different places where the industry tried to fix a problem. As you saw, SQL injection risk is not something new. It has been existing from 2017. So it's on the top radar also. So the industry had their traditional legacy methods and they had different ways to fix this problem, right? So the first thought process was my application should not allow any malicious SQL to pass through. So at the application layer, you filter it out and just validate and forward only what is not malicious. Now, these were the traditional approaches at the application layer, improving the user authentication, enforcing least privileges, using prepared statement, avoiding dynamic queries, performing input validations. Not that these things should not be followed. It is always a good security practice to follow these at the application layer, but this has often failed to curtail the SQL injection. Now, it's not reliable since like here we are dealing with development and configuration controls, which are again not automated, which are done by development. So which are done by the people, right? It's a manual process. So it's always, you will always hear like, misses there, the configuration controls being, there are misses in the configuration control. And of course, you can't fix these problems in the packaged or the legacy applications. And new vulnerabilities are found all the time. So you cannot enforce these things on the application tier. Now, that's the reason, like, we have seen an upward trend, though these traditional approaches did exist. And this is like a growing number. If you see the CVE security vulnerabilities trend for SQL injection, it's upward trend since 2021. 2023 was an all-time high. And 2024, we're just nearing that all-time high, which means like, it is going to grow past this number of the previous year. So the traditional approaches clearly hasn't, curtailed any of the SQL injection risk, of course, to some extent of known things, but any new things, new vulnerabilities, zero-day exploits, I don't think traditional approaches is going to help. Now, let me tell you, like, why web application firewall again has failed to, curtail that risk. Web application firewall is a thought process where the thought was like, before the application receives those inputs, the WAF should recognize what the SQL injection pattern is and block it. Well and good. If it is kind of a known vulnerability, it's obvious like you can add those patterns, like known patterns into the WAF and say like, if I receive any traffic with those known patterns, you block it. Else you just leave or go through it. But they don't live up to expectations because they are helpless for zero-day exploits. If there are newer patterns which is not included in those WAFs, because WAFs relies on just on regex pattern search. If they don't, if they are not included in those blocked deny list, then obviously it doesn't recognize, it recognizes it as a allowed list and it just allows it to the application. So zero-day exploits, WAFs don't live up to that expectation. And of course, since it operates at a layer prior to application, it will not have context of what actually the intent of the SQL query is. For example, like if you have a table and you have configured a WAF rule saying like this query on table you allow and rest you block it, And now if someone creates a synonym on that table, so that is not something which is there in the WAF rule. So I can easily fool my WAF saying like, query by the synonym and get everything because there isn't anything on the synonym, right? So it cannot use that SQL context. It cannot use the intelligence that is there in the database to execute that query to make a decision. And that's where the WAF actually fails. They don't live up to the expectations at all. Now, what about the third approach where you have some kind of database firewall that understands application SQL, it understands the intent of the SQL and block everything that is not normal, not expected by the application to query, right? And that's where the database filters, database firewalls comes into picture. They are strategically positioned to address the problem and looks more promising because they work from the allow list. They look at what is allowed to be processed for that application, and the rest you can have a way to observe the traffic. You can block them if you want to. And all these, many of these execution decisions are based on the intent of the SQL. So, like, the synonyms or like, your dynamic objects instances, those can be well known to the firewall engine if it is working closer to the database. Now, from Oracle solution to block SQL injection attempts or to observe it and to kind of bring it into the visibility, there are two solutions that are offered. One is if you have used database firewall in AVDF, that's a solution that you already have. The newest solution is what is built into the database, built into database 23 AI onwards. That's the Oracle SQL Firewall. So if you're looking from the perspective of the SQL injection risk to curtail them, you can offer either of them. I have a slide explaining like what are the factors that you should take into account, like, if you were to choose database firewall or SQL firewall. I'll come to it in a minute. But both of these solutions learns the typical application SQL traffic, constructs that allow list of what is learned, and then reject or alert on anything that is not in the allowed list. And it's a perfect solution for zero-day exploits because the allow list is a definite one, right? So you don't have to be worried about what is the infinite deny list. So you have a set of things that is expected and you allow something based on only on those expected lines. Now, SQL Firewall, going into the details. Now, the most common thing is the two most common use cases is restricting database access to only authorized SQL statement and connections. So it helps mitigate risk from SQL injection attacks, anomalous access, and the risk of stolen credentials. It controls which statements are allowed to be executed by the database, which database connections are permitted into the database, right? It can enforce those trusted database connection paths. Now, it is strategically positioned because it runs within the kernel. So it has visibility into all the traffic compared to a network firewall, which is outside the database. This one, since it's running inside, so if there is anything bequeath, or if there is any stored procedure execution, it has visibility into everything. So you don't have to worry to make changes to, route everything into the network database firewall. This one is running inside the database. And it's quicker deployment because there is no client configuration that's required. All you have to do is enable this in the database and train for that particular database user that you wish to protect and enforce it, and you're all set to go. It's quicker deployment, quicker scales across your estate. It has full visibility, and there is near zero performance overhead. And I'll just talk about it in a minute. It's available only for Oracle Database Enterprise Edition 23 AI and above. Now, coming to the licensing perspective, right? SQL Firewall must be licensed for use. It's included as part of Oracle Database Vault. It's included as part of Oracle Audit Vault and Database Firewall. Now, since it's included in Database File or Vault, most of your DBaaS OCI offerings, since it has Database Vault, you will also see SQL Firewall. So your autonomous database, your Exadata database service offerings. So multiple of them do include the SQL Firewall by default because Database Vault is also included in them. You use data safe largely to administer and monitor the SQL Firewall for database, Oracle database that have appropriate rights. Okay, so now what is a competitive edge over any typical network-based database firewall, right? As I said before, like there isn't any requirement of client network reconfiguration. Talk about any network database firewall, there is a certain amount of client rerouting, right? All the client traffic must be routed to the database firewall instead of the database, and the database firewall talks to the database, right? So here you don't have to worry about it. Now, if you have the network database firewall, unless you have in the HA deployment mode, that turns out to be the single point of failure too. So you need to have the HA deployments, which are relatively little complex. Now, if you have encrypted SQL traffic, either you have to terminate it in the database firewall, or you need to configure the TLS exchange between the database firewall and database. And of course, the database firewall over the network has the limitation that it can see the SQL traffic that's coming over the network, but it doesn't have visibility into what runs within the database, your stored procedure execution or your local direct access connection. It doesn't have visibility. Now, and also like limited execution capabilities because it cannot give you the real object information. For example, current schemas, the synonyms, it usually has that limitation that it cannot resolve those things. Now, SQL Firewall within the database, it will not have any of these constraints. Now, if you're using other security controls, right? Like, for example, database auditing, database vault, or whatever it is, SQL Firewall works in conjunction with all these. And if you look at this matrix, of course, the slides will be shared over those portal. You can take a look at it deeper. But if you look at it, like SQL Firewall is the only solution that can help allow list the SQL statements for SQL injection. The other ones like database auditing, you use it to monitor what is abnormal, right? It's tracking all the DBA activities, tracking the privileged user access, any kind of security relevant events that's happening on your database. That's all done with database auditing. Database vault, any kind of sensitive object access, any kind of privileged user access. That's where you would use typically database vault. SQL Firewall, yes, you can use it for allowing known SQL statements. And that's where it can actually coexist with many other things and work in conjunction to bring a holistic security solution. Now let's go into the use cases, right? Two prominent use cases. One is which helps mitigate the risk of SQL injection, allowing the approved SQL, what is allowed and what is learned by the system. It will allow only that. The rest, it will give you as a violation, or you have a way to optionally block it. The second is you can enforce trusted database connection path. So any kind of anomalous access or any risk of stolen credentials coming from a non-trusted path, you can say like, block it. Let me just show you, illustrate here. For example, this is a SQL firewall with a learned copy, right? So this is my allowed baseline, allowed SQL statement that is accepted by the database. What is the accessed object, the current user. So we constitute this allowed baseline of what is accepted. And when the normal user queries, and this query is one in that allowed list, we actually generate a SQL signature and we do a syntactic mapping. So if it is allowed, it is allowed to be executed by the database. Now, assuming we have a malicious user, so if this is a case of SQL injection, it will not match to what is in the allowed list. And so the database is, you can optionally say, I want to block this particular statement from further execution, or I want to alert it to my security administrator. So you have a way to configure. Similarly, for enforcing trusted database connection paths, the allow list also has the session context attributes like IP address, the OS username, and program. We have 3 today, and we plan to extend that in the future. So if it's from a known path, we allow it for execution. If it is in an unknown path that is not configured in the allow list, it would be blocked from execution. So these are the 2 prominent use cases, and this is quite a typical thing for someone trying to protect against the stolen credentials, because they cannot use it from, say, SQL developer or another program which is not authorized. Okay, so how do you get started, right? So we have talked about the good features. How do you even get started with SQL Firewall? There are multiple ways we give you to manage and administer SQL Firewall. One is in the data safe. If you have used the data safe OCI cloud service offering that we have in our security solution, that provides a very neat, very user-friendly and intuitive way to configure and get started. Or you can use a PL SQL. There are PL SQL APIs, the DBMS SQL Firewall. So if you're so comfortable with the command line and the API mode, you can actually do it with the PL SQL as well. Now, SQL Firewall in Data Safe has an added advantage. Like we give the visibility of configuration and monitoring across the fleet. If you use a PL SQL way, it's to be done within each database, right? But the SQL Firewall configuration in the data safe, we allow you to configure across your database fleets, provide the visibility into the violations, and of course, you can integrate with larger OCI ecosystem. For example, your alerts from the violations, you can actually tie it to OCI events and notifications to trigger alerts. Or you can use the CLIs, the SDKs, the REST for automation. Now, getting started on either your PL SQL or data safe is just 3 steps. We have made it so simple that, a layman can start configuring. You don't have to be an expert. You don't have to be a DBA to kind of know all these things. It's very easy. All you have to do is, I'll take you through those 3 steps, and then I'll show you in the demo as well. In the data safe, you have SQL Firewall. First, you need to enable the SQL Firewall in the database. So we give you the configuration to enable it for that target. Now, the same thing, if you want to do in the PL SQL, yes, there is a PL SQL API to also enable it for the target. We haven't enabled by default. You have to enable this one. Now, the second step is for the user that you wish to protect, you need to configure the allowed list and the policy. Now, policy is nothing but an artifact containing what your allowed baseline is. So if you go to SQL Firewall, SQL collections, you can basically have for the target, you can get the user. Typically, that's the application service account. So you start to collect. Collect is where you would train the system for the approved allowed SQL statements for that user, right? And there is a way where you can run the workload, capture the good SQLs, capture what is permitted SQLs for that SQL, for that user, and you can basically monitor it from the convenience of the OCI console. We have SQL collection insights. As soon as there are no new incoming SQL statements and it remains at 0, you can be rest assured that you have captured the SQL statements that is allowed, that is permitted for the database user. Of course, we give visibility into the SQL statement in the collection phase. We also give visibility into the trusted connection paths that is coming from the application workload. And then you can generate the firewall policy once you are sure that there are no new application SQL statements that is expected for that particular database user. Now, the third step is once you've collected, we give you that visibility into the allowed SQL statements and allowed context attributes. You can modify them if required, and you can enforce it. Now, once you enforce it, you have a couple of options, and let me just spend a moment here. Now, in enforcement, like you have three variants, right? Like you can enforce the allowed, the context and the statements, or you have a way to say, like, I can enforce only on the session context or allowed SQL. So it's a combination. You can choose the combination. For example, if you want to start it from day zero, right? The session context would be the most easier one to start with. SQL statements, as your system trains over a period of time, and you know what is my allowed SQL statements, so you can have a little bit of days to actually switch to both. So start with session context, and when the system is completely trained for what is allowed, you can switch to both and say you can enforce my checks now on both of them, right? And then you have a way to say, like, if there is a violation. Violations are basically events where there is a mismatch of the traffic, incoming traffic, with what is in my allowed baseline of SQL statement or session context variables. So you have a way to say, like, you just observe it and log the violations. We have a violations log metadata in the schema where we log every mismatched event there, and that will actually be surfaced. I'll show you in a minute. It'll be surfaced in the data safe, or you have a way to query that as well. Or you can say any violations, you block it. Don't even attempt to go into my database. Block it then and there. Now, the third option is you might want to audit the violations. Violations in a fully trained systems are abnormal access pattern. So it is good to audit them and show them to the auditors for the regulatory compliance. So on a well-trained system, you would typically turn this on to audit any violations. So we give you these three options, and you have a way to change at any point in time and to change the, if for example, a firewall policy is enforced, you can change it anytime and you can deploy it. It's real time, effective on the database. Now, you would repeat this process of collection and enforcing for each database user you wish to protect. So if there are like multiple accounts, like you would do that for every account, you would do this collection and enforcement. Now, apart from just the collection piece, right? So once these policies are enforced in the database, the violations, it looks at the incoming SQL traffic and matches against what is my allowed baseline in the policy. If there is any mismatch, that's a violation event. Now that will be collected by DataSafe automatically. You don't have to do anything. It will be collected and stored in the DataSafe repository. It will be surfaced in the UI as charts. Like in your dashboard, you have the SQL Firewall violation, you have a report. You can also use, leverage the alerts, the predefined alerts to, bring that to the notice of the administrator. Now, if you're not using DataSafe, of course, you can query the violations log and, sync up to the whichever system you use. Now, the other cool thing is, now, once you've constituted the baseline of allowed list, right, there are always cases where you want to update them. Probably an application change or a patch change has caused some statements change, or some changes where you allow a different trusted path. At any point in time, you have a way to edit those allow list and include what is new, right? So we give you that flexibility where you can add from violations, and that goes into the allowed list. Or we also give you the flexibility where you can modify the session accepted session parameters, and you can include or exclude anything, and it will be effective as well. Now let me, and also like since data safe, like we do provide SDK, CLI, Terraform, you have ways to do automation integration. Now let me give you a demo in the real world. Are there any questions? Okay, it's been relatively calm. Okay, let me just show you the demo. Okay, I don't know how many of you are familiar with DataSafe. DataSafe is the cloud service, and many functionalities are exposed from the database security solutions in DataSafe, and one of them is a SQL Firewall. Now, the SQL Firewall functionality that's available for 23 AI database. So this is the dashboard where you can see quick visibility into the violations that are in my state, what is the kind of enforcement mode, and what is the collections that is in the system, right? So for one of the target database that I have discovered and promoted into the data set, let me drill down, and here it is already enabled. So by default, it would be disabled. You would actually toggle this option to make it enabled. Now, once it's enabled, you would start, of course, I've created the collection. So, but basically what you would do is pick up the database user and you would start collection. Starting the collection means that you are in a phase where you are training the system to know what the allowed SQL statement, allowed session connection attributes are for this particular user. Now, let me show you what is already collected for this user. Now, for this user, I have the collection, I have already collected. And if you see here, let me just, it was collected long back. So these are the SQL statements that I have run from one of the applications. This is the HR application. I've run that SQLs. So what has been collected actually shows up here, the count and how many of my the session attributes, the client IP, the OS user, and the program, right? All those shows up in the collection phase. Now, if you go to the SQL Firewall policies, right? For this particular user, let's just give a minute for it to load. So typically you would be generating the SQL Firewall policy, but this is already an executed phase. So I'm showing what has been done already. So once you have collected, you would actually generate the firewall policy and you will come to this page. Now in the policy page, you would see what has been collected, what constitutes my allowed baseline. So this is a set of what is my allowed session, allowed trusted database connection paths. So the database will only allow the SQL statements coming from this IP, this OS user, this client program. It's going to alert or block. I've given this for block so that it will block it. So anything else apart from this 3 client attributes would basically be blocked. You have a way to just observe and log the violation, but for my instance, I've given it block. And the SQL statements that has been collected as part of the collection phase is listed here. You have a way to modify it. If you want to delete a specific one, you can just choose, you can delete one of them. Or if you want to add something new, which has come to the violation, we give you that workflow where you can just pick up, you can see the query and you say, okay, this is what is acceptable. You can add it to the allowed baseline. And of course, we give you the flexibility to generate an offline report. So if you have third party, like you have to validate these SQLs with a third party or a different vendor, you can provide them this report and ask them for validation. And now let me show you real time how it works, because now here, what you see here, I have set this to blocked instance. So any mismatch is going to throw me ORA error, right? So, and I have a set of allowed session attributes and allowed SQL statements. So this is a HR application. Let me just log in. And if you're wondering, like, how do I build this one and demonstrate, this is all based out of Live Labs. So you basically have a way to, stage this entire thing in just 15, 20 minutes. That's all it would take. So your entire setup, your sandbox instance would be available with the OCI, with this application, and you're ready to get started. Now, this is a typical HR application. All these SQL statements I have in my allowed list. So it is, making me query. So without any issues. Now, what if I have something, let me just show you. If I don't have this in my allowed SQL, right? So if I do this, I am greeted by this violation. ORA 47604 or 605, sorry, it's the ORA error for the SQL firewall violation. Now, later I realized, of course, this should be in my allowed SQL statement. Why it is not? Then I can actually go. Before I go there, let me just show you. That would come up in the violation report. Okay, so it takes a while. Let me show you from here. So these are the violation reports. It takes a moment for it to come up. So while we wait, I'll show you the other portions. Like in alerts, we have a default, the predefined alert. That's for the SQL firewall alert policies. If you see SQL firewall violations, so basically you can, for any violations that is there, you can actually associate to the target, can deploy it to the target, and it will kind of fire those alerts if it detects any violations. So let me go back. It should have come now. Violations report. Okay, here you go. So if you can see my screen, so you have a violation here. And if you see, that's a blocked violation. And you can basically expand to see what is the query that has been blocked because it's not in the allowed list. And somehow my administrator realizes this, that should be in the, kind of allowed SQL statement. I need to go back and add, right? You can see the same thing come up in the dashboard also. You would see this as one violation, and you can basically drill down to the same chart. Now, if I need to add that into my allowed list, I would go basically into the policy, add from violations. So this is the one which has been raised recently. I go add to the violation, add from the violation basically. So it updates the allowed list with the current one, and it increases the version number. So this is the third version of my allowed SQL statement with this. Now, if you see, I haven't done anything to redeploy or do anything, right? Now, if I fire the same query, I would be seeing the result. So it's very simple to manage it, manage the SQL firewall from the data save because you have the UI. Of course, the same functionality is available from the PL SQL if you want to add it to from the violations and see it in real time. So that was the demo. Now, a quick view into how the SQL firewall enforces the checks, right? So SQL firewall policy is nothing but you have two set of allowed statements, right? Allowed SQL statement and allowed context. Allowed context is based on those three session context variables: client IP address, OS program, OS username. And it's enforceable during session connection. So if there is any traffic that violates any of this, what you have, then it is basically the client connection is terminated. Now, the SQL statements, we constitute from what is in the learned list. Again, we store the SQL signature, the execution context, not just the SQL signature, but the execution context. It is enforceable during the SQL executions. So if there is a mismatch against the traffic, it will give you that ORA error, but we don't terminate any client connections. Now, assuming you have the SQL statements, database connections coming, the incoming one. So based on what you have enforced in the policy, either you have set the enforced context, or you have set enforced SQL statements only, or you have done for both, it checks against these things. If you have enforce all, it checks against both. If you have context, it checks against what is there in the allowed context. If it is enforced SQL, it checks against the allowed SQL statements. And if there is any mismatch, that's a violation. Now, violation, if you're just observing, it goes to the violation log and it allows the SQL statements to process. So just observe, the SQL will continue to be executed, but you will see in the violations. But if you set it to block, we don't allow further SQL execution, and it will raise the 47605 violation, and you would see that in the violations log. So that explains how this entire mechanism works. Now, one of the frequently asked queries, I'm just keeping a tab on time. Of course, you can see the entire FAQ list that we have compiled based on the queries that we have received from the field. And this is a growing list. So if you have any queries, you can let me know offline as well. And if it's not something which we have already captured, we'll keep adding to this list. One of the important things that we keep hearing is if you have existing database firewall investment, which one should I use? Whether it's a SQL firewall or database firewall, because for SQL injection, both are equally good at it. These are the top 5 factors that you would consider. Of course, we have documentations which explains the complete list of considerations that you would typically factor in. But if it's your non-Oracle database, right, your database firewall is the obvious choice, because SQL Firewall is only for the Oracle database. Again, the versions, Oracle database 23 and above, it uses SQL Firewall, not the older versions. And coming to deployment considerations, right? If you have existing investment on a virtual machine or hardware where you've installed database firewall, continue using that. You can do the blocking with proxy. Of course, little bit of networking changes are involved, but then you can configure the proxy to also block. SQL Firewall, it doesn't have any client configuration. It's simple, scalable across your fleet. Coming to performance considerations, right? Since it's running database inside the database, of course, there is a overhead, but we have done a lot to improve the performance. Like it will not exceed more than 1% or 1.5% in all our internal testing with the mixed workload. We haven't seen crossing 1 to 1.5%. Even if all the SQLs go to the violations, we haven't seen crossing this. So there is very negligible overhead on the system. In fact, we use all the fast ingest feature within the database to make it very performant. And of course, there is no observable latency. Database firewall, since there is no processing overhead on the database, there is no overhead. And again, like it depends on the deployment model. For certain deployment models like host monitor, you might see we do give sizing advisory on how you should have that host monitor, right? And you would see a little bit of latency overhead, and this is dependent on the SQL traffic also, this is well documented in our guides. Now coming to the inspection scope, since SQL Firewall is kernel residence, it sees all the traffic, including Beckwith, internal jobs, stored procedure, traffic over the network. Database Firewall, it monitors SQL traffic coming over the network. We typically recommend customers to augment with database auditing for a complete holistic visibility. So these are the 5 factors that you would typically consider when you want to decide between SQL Firewall and database firewall. Of course, in AVDF, you have a way, you will have a way to monitor, manage SQL Firewall very soon. So to summarize the entire thing, SQL Firewall, introduced in 23 AI, provides real-time protection against the common database attacks. It restricts the database connections only to authorized and approved SQL statements and connection, a perfect solution for SQL injection attacks, anomalous access, and stolen credentials and abuse. And you have multiple management models. And of course, we are expanding that management interface also. Of course, DataSafe offers a simplified management with the convenience of OCI console. And coming to the learning resources, right? Of course, if you have not seen the ebook yet, there is this one little technical primer document where we actually summarize all the DB security solutions, including the SQL Firewall. You have live labs, the entire demo that I showed you with the use cases. You can always use the live labs to stage a sandbox instance in 15 minutes and get started. And of course, you have the YouTube channel where we have a couple of videos, and I would also be uploading some more with the demo of 2 use cases that we talked about. And of course, we have the technical report on SQL injection risk mitigation solutions with AVDF and the SQL Firewall, and how you can configure both of them. And other collaterals which we have with GitHub, then the documentations. Yes, and that's pretty much from my end.